La siguiente charla estará a cargo de Boris Sassenrach y Peter Weinmoller de Becoplan Fuel Track, quienes nos hablarán sobre combustibles alternos, procesamiento de desechos sólidos municipales, desechos industriales y otro tipo de desechos sólidos que se pueden usar como combustibles en los precalentadores y en los quemadores principales.
Okay, good afternoon, everyone. Thank you for attending. Thank you for the nice introduction. Topic today is alternative fuels, processing for fuels, for main burners and preheaters. And I have to say up front, I do not have a magical solution for you. The processing is a complex process and it does cost money. So first, the agenda, a quick introduction into the company, the product range. Then I will touch on the main fuel streams that are available for the cement industry. We will go into the different steps of the production of the fuel. And I have two small case studies to show you how the systems look in reality. Vicoplan is a small German company founded about 40 years ago with a focus in the recycling industry. You know that in Europe since the 80s there is a lot of recycling and the substitution rate of cement factories in Europe is at 50% or above. So the technology for the preparation as well as on the cement side is available. The product range covers the complete process from the initial shredding process to the fuel preparation, various forms of separation, transportation on site, and the storage on site. Some of you may remember last year I had a presentation. I was focusing on the storage and the transportation. It's a huge issue in the plants. The presentation itself, what waste streams are available? One of the major waste streams, at least in North America, is construction and demolition waste. Construction and demolition waste is mostly directly from the construction sites. It is not sorted. It contains of wood, of shingles, of concrete. It is very abrasive. It has a large variety in density. And at the end, it has little BTU value because the content in wood is extremely high and wood has, compared to other alternative fuels, a low BTU value. Another very popular fuel are tires. Tires, in this case, are chipped. The chipping of tires is a costly process, and there seems to be a tendency in the cement industry to use tires as a whole, to avoid the process of shredding it. Tires are extremely abrasive to shred, so good for the manufacturers like us. We can sell big machines and a lot of spare parts, but for you, as the users of this fuel, you're only interested in the calorific value, and the shredding does not really add to that. So tires, they are expensive to process. Also, tires are limited. Every country has a certain number of tires per inhabitant, and those numbers are very stable. So you cannot assume that tire consumption goes up. This is a good one. A lot of you know this. Industrial wastes, different forms. They come as clean waste. Usually they are dry. There is very little contamination, and there is a relatively high calorific content. This, you can see, this is where the money is. This is hazardous waste, And many cement companies try to process this waste, and it is possible to burn it and to charge a very high gate fee because the charging and the landfill is almost impossible. So this is a very, very interesting product group, all kinds of industrial waste, but industrial waste is limited. It is a beautiful fuel, but I call it is the icing on the cake. You have to remember that every big industry, every big car manufacturer, every big carpet manufacturer, every paper manufacturer, they are producing a product. They are not producing waste. So their focus will be to minimize the waste. So it is very difficult for a cement plant to start a project on alternative fuels based on industrial waste only. If you're really able to find one supplier that can give you 30 or 40,000 tons of industrial waste a year, you're in a very, very lucky spot. So you all know what the next slide is. I present the winner. The winner is municipal solid waste. Why? Because it is unlimited and it is everywhere. Municipal solid waste is a problem for a lot of communities as they do have an existing waste collection system, but they only have one landfill. Or very large cities like Lima, maybe you have 2 or 3 landfills. But those landfills have a certain expectancy for the lifespan. Once you fill up your landfill, it is extremely difficult to find a new location and a new permit for another one. So the municipalities or the private owners of landfills become more and more aware of the fact that their business model is looking at a certain end. It's a cul-de-sac that may be 10 years, 15 or 20 years, but you pretty much know if I continue to put so and so many tons into this hole, in so and so many years I'm going to be full. That's the end of that landfill. Mexico City, for example, is starting to go into mining into landfills because of this problem. So municipal waste is, in our opinion, a huge resource, and in many cases, the waste that goes into the landfill, even after the valuables like metals or special plastics have been taken out manually or automatically, 20%, 25% of the material that is going into the landfill is good fuel for the cement industry. After any other recycling processes, we are still looking at 20 to 25% usable material. So the numbers here are huge. And this is a source where you can get 100,000 tons a year. And you may think this is a big number, but if you use 10 tons in your preheater, and you run your preheater 8,000 hours, you have 80,000 tons right there. And believe me, 10 tons for a big kiln, you are way below 50% substitution, way below. So the numbers you are looking for have to take this into consideration at some point. Now, we have been talking about waste, but waste is not what you want. You want fuel. So how do we get from waste to fuel, and what's the difference between fuel and waste? Waste is basically all material stream coming in. For the fuel, we have 2 main classes, and this is not a final, this is like an orientation. In general, you have the main burner fuel, we call it sometimes a king class fuel, where you have 2-dimensional material, a very low density, you have a size limitation, and the moisture content, I'm saying 20%, if it's lower, it's better. For the preheater and the calciner, the scenario is a little bit different. You have 3-dimensional material, for example, biomass would fall into this. You have much more tolerance on the density, and, very important, your sizing can be, depending on your retention time in the calciner or in the preheater tower, can be 80 millimeters or more if you have light material. Moisture content, again here, this is a general number. In general, the drier the better. The problem is, very often you cannot get dry material. So the problem here is not the water, the problem here is that the water replaces cement capacity. First step, since the material comes in various forms, we have a pre-shredder. The pre-shredder is a very, very rough machine which has a configuration basically to take any size material and bring it down to 300 or below 300 millimeters. This is all this machine does, just to enable a more homogeneous flow into the production. Next point is specifically for municipal waste. Here we have a waste screen. At this point, we are separating the organic and small inerts from all the other waste. If you do not have organics in your material flow, you can use manual separation. Usually, you have this one first, then you may have an optional manual picking to get out the valuables. But if you have organics in your stream, you need to take those out because that is definitely something you don't want in your fuel. It is important to consider this because if you look at a pie chart from typical municipal waste, about 50% are organics. So if you look at a huge production line, let's say 60 tons an hour, you will look at 30 tons an hour of organics. So you have to deal with that. Sorry. The second point would be a density separation. You remember a couple slides back, we talked about the density. The screening and the picking usually only goes for large pieces. But what do you do if you have a small piece of shoe or a small cap of a pencil in your fuel? Or you have a stainless steel piece from a modern Hewlett-Packard or other printer. All of that is in your waste stream. This we're taking out with a density separation, which is basically a complex form of an air knife. You will generate two streams. One is the heavy parts. For example, everything that is more heavy than 0.25, if you're looking at the back end of your production, or everything that is heavier than 0.15 if you look for main burner fuel. And the light fraction, the remaining plastics, the remaining textiles, the remaining paper, cardboard, all of this material goes into the fuel stream, and this is fuel quality material. But we have another criteria. We not only have the density, we also have the size to guarantee a good combustion process. So we have a second shredding step. For this machine, you can have various options depending on the size of the project you have and the throughput you need by hour. In this case, we have a machine with a hopper, which can take material here from the production, but which also has the opportunity to take clean material, which you may buy in very small quantities. For example, if you have a paper factory close by, you may be able to buy 5 or 10 tons a day of clean paper waste, which comes already in bales. So you don't have to pre-shred it, you don't have to screen it, you don't have to use density separation because you know what's in that bale. So those bales you could introduce into this reshredder at this point, bypassing all the other equipment. This machine runs on a mechanical base. It's a slow rotating rotor. You have a pusher that forces the material into the stream. And since we're talking waste, we have an air spring counter knife, because with waste, the question is not if you will have a crash, the only question is when you will have a crash. You can have as many density separations and ferrous separations upstream, something will pass through. And if it's only your own mechanic who does a job after all those machines and leaves one of his big Allen wrenches on the belt, when you start it, it will hit your machine. So this is why these machines are designed to have relatively small particle size. This is where we define 50 millimeters, 80 millimeters, or 30, 25 millimeters, depending on your process requirements. You can see the counter knife here is accessible because if we go back, if you imagine that you're running this at, let's say, 10 tons an hour, you have a lot of material in here. When the machine stops because you have a crash, in that case, you will want to be able to access the machine from here in order to minimize your downtime. You will not take your personnel, put that in the hopper, and empty the hopper 10 cubic meters to get to the point of the contamination. You want to be able to do it from the underside. So here you're looking at 15 minutes and you're back in production. Another form of reshredder for higher volumes, up to 20 tons an hour, would be a machine which we call VEBS. You can see here this machine is only suitable for continuous feeding. So the equipment that is on this side, on the upstream side, has larger volumes. And although you have the larger capacity in the processing, you have the disadvantage of not being able to insert additional clean material, industrial waste into this machine. Slightly different applications, same product. One little excursion, we spoke about moisture. It is difficult to get the moisture down consistently. So there are generally two approaches. You have continuous drying, which can be installed in the cement plant. The advantage being is that in the cement plant, usually the energy to dry is available from flue gases, so no extra operational costs. The other option is to work in a batch system, usually already at the landfill or at the processing company, where you have systems that take the material stays for several days, and the organic matter in the material creates the heat that's related for the drying. So in this case, you just need some small ventilation systems. Another point in the production is the sampling. It is important to take representative samples. It is important to be able to take samples 24/7, and it is important to have those samples taken automatically because, at least in Europe, we have this infected needle scenario, and because of that, it is illegal to have an employee go into the material and take a grab sample. You never know what's in there, and you want to protect your employee and eventually your company from those risks. Final step, when you're all done, you have your product, and there's basically no more added value. So at this point, you have to decide, how do I get it to the customer? If you're the landfill operator or if you're a joint venture, usually there is a transportation. Transportation costs are extremely important in the overall economic calculation of such a project. And this is why we recommend a highly automated system where no more personnel is involved. People equalizing the fill levels of containers, there's zero value. You have to be able to get those in a continuous flow. And if you talk about serious productions, 8 tons or 20 tons an hour, you will have one of these every hour. So there must be a certain way to maintain your production running. The volumes are important here. Case study. This is just a drawing to show you how these systems can be really complex. We have a production here. We have a complete drying system. And after the drying, we have the reshredding and the on-site storage. And from the on-site storage, you can go to the cement factory. And there's a small area here which has a baling unit to bale valuable materials. I'm a little bit running out of time. A simple system for main burner fuel production. You see the main elements: pre-shredder, ferrous separation, density separation, and the reshredding. And this is what these systems would like in reality: pre-shredding, screening, ferrous separation, reshredding, and then you go into a storage or into the truck. Time is up. Thank you for your attention. Thank you for translation.